Hey guys, so we are reaching to the last topic of the chapter. Today we'll start our class with a very simple question. My question is, why do balls bounce? Right, this is a ball that we've been using for all our activities. If I smack it on the table, it bounces. Why does it do that? Why does it not stay flat? Or anything, right? Why does it happen? Simple question. We're going to answer it through our topic today, right? So today we will talk about third law of motion. Okay, we already studied law 1 and law 2, right? We're going to look at the third law, which is also made by Newton. Now if we understand that law, we'll understand why this ball is bouncing. Other than just the ball bouncing, there are like hundreds of places you'll have seen this law working, but you never realized that it is this law only. Okay, so I'll tell you what this law states. You must be familiar with this law. Every action has an equal and opposite reaction. Probably heard it in a movie somewhere or something, right? That is essentially what the third law of motion states. But that is a very simple way to put it. In physics, we talk about it like this. When one object exerts a force on another object, okay, when one object exerts a force on another object, the other object also exerts a force on the first object. Okay, so say that I have object 1, this ball, say object 2, just my fist. Okay, if this ball is hitting my fist, by hitting I mean it's using some force to strike it, right? It means that this fist will also put some force back on the ball, right? And this force is always equal but in the opposite directions, meaning say this ball hits with a force of some F, okay, even the hand will hit back with the same amount of force F but in the opposite direction. Okay, let's try to enact it in a simple way, right? Ball's moving, collision, force is happening right here where the hand and ball are touching, right? My ball is moving in this direction, which means the first force is in this direction, but my hand is going to put the force in the opposite direction, which is that direction, right? You saw the reaction, right? The moment it hit my hand, it moved back, which is the opposite direction of this ball's movement, right? So to summarize third law, an object that exerts a force on another object will experience a force back on itself, okay, and the same amount of force but in the opposite direction. All right, now this is the same reason why a ball will bounce. Okay, it's pretty much the same, except this time it's not my fist, it's the table, right? I drop the ball, it has some energy when it's moving, some force, it crashes, hits the table. The moment it hits the table, you think that it's just the ball hitting the table. What you don't see is the table is also putting a force back on the ball. Okay, that force is the reason why your ball is going to bounce, and you can do that with almost anything, right? If you notice, if I drop the ball slowly, it will bounce to a certain height. If I add a little more force when I'm throwing, you will see that the bounce is more because the force is equal again. So even if I hit it with more force, the table is going to hit us back with the same amount of force, which is why the bounce will be much more. Clear? Now, where are other places that I have seen this law working in real life? Simple example is walking, right? Whenever you walk, you don't realize this, but every time you put one step in front of the other, you are pushing the ground with the foot that's on the back, right? You're pushing it off and you're moving forward. Whenever you're pushing a foot off, what's happening is you put force on the ground. And the ground is pushing force back, which allows you to put your foot forward. That is how we are able to move, right? Along with that, another example is simply how birds fly. And if you see birds flying, how they fly? They flap their wings, right? So what they're doing when they flap their wings, they push the air down with a certain force. Now we know that the air is also going to push them back with the same force but in the opposite direction. So if birds push down, the air pushes the bird up. Right? Again, opposite directions, same force. Alright? Now these are called as action-reaction pairs. Okay, action-reaction pairs. So the first force is the action force, the second force is the reaction force. Okay. So mathematically, if I have to show this, I'll show it simply. It's a very simple formula. Okay, force by first object on second object is equal to force by second object on first object, but in the opposite direction. So I'll put it like this: F of 1, 2. F12 is nothing but force of first object on second object equals to minus F21. Okay, F21 means force of second object on first object. The minus shows that its direction is opposite. That is all. Alright. So this is the third law of motion for Newton. It's a very simple way to understand it. It's one of the simplest laws also. Going forward from tomorrow, what we are going to do, we will look at certain activities that we can do for this. There is one activity I do encourage you to do if you have the material with you. Okay, take a thread, okay, take a straw, take a balloon, okay, blow up the balloon, okay, and tape it to the straw. And then put a thread through that straw, maybe hold it apart or just get your friend or someone to help you out with this. And then you leave the balloon from one side, you will see it just goes flying, zip, which is going to go fly along that thread. Okay, you will be able to notice the third law of motion in action very simply, right? Because the air pushes back but the balloon moves front. That is again the same example. Balloon pushes air, air pushes balloon. Cool. Okay, I do encourage you to try it out on your own. From tomorrow we are going to look at couple of numericals, maybe some formulae, and we're going to practice all of this going forward. That's it for today. Simple class. Thank you so much. I hope you understood. I'll see you in the next class.